There is a monster in the dark, a region of space where gravity is so absolute that not even light can escape its grip. We look at them with a primal mixture of terror and fascination. We imagine the journey into the abyss, the stretching of space, the stopping of time, the inevitable spaghettification. But what if that journey has already happened? What if the reason we cannot find the edge of our universe is because we are looking at it from the inside? The Matryoshka universe. To understand this, we must look at the Schwarzschild Radius. In 1916, Carl Schwarzschild realized that any object becomes a black hole if you compress it enough. If you crush the Earth down to the size of a marble, roughly 9 millimeters, it would become a black hole. The math is simple. The radius depends entirely on the mass. But here is the counterintuitive twist. As the mass of a black hole grows, the density required to create it decreases. A solar system-sized black hole requires crushing density. But a black hole the size of a galaxy? It would be less dense than the air you are breathing right now. Now, let us do the ultimate calculation. Take the total mass of the observable universe, roughly 10 to the power of 53 kilograms. Plug that mass into Schwarzschild's equation. The result is a radius of 13.8 billion light-years. That is exactly the size of our observable universe. Mathematically speaking, we meet every criteria for living inside a black hole. If this geometry is correct, it redefines our history. Standard cosmology says we came from a singularity, a point of infinite density. But singularities are exactly what lie at the heart of black holes. In this theory, our Big Bang was actually a white hole. Imagine a star in a parent universe collapsing. It tears a hole in space-time. Matter falls in, but it cannot be destroyed. Instead, it bursts out on the other side of the singularity, expanding rapidly. To the parent universe, it is a collapse. To us, on the inside, it is the Big Bang. But the strongest evidence comes from the nature of information itself. In the 1970s, Stephen Hawking and Jacob Bekenstein discovered a paradox. If a black hole destroys matter, it destroys information, which breaks the laws of quantum mechanics. Their solution was profound. They realized that when an object falls in, its information, its quantum data, is plastered onto the surface of the event horizon. Think of it like a soup can. The label on the outside describes everything inside the can. The maximum amount of entropy or information a region of space can hold is not determined by its volume, but by its surface area. This is the holographic principle. If we are inside a black hole, the surface is the edge of the observable universe. Every star, every atom, every second of your life might be a three-dimensional projection of two-dimensional data stored on the cosmic horizon. We are the shadows on the wall of the cave. This leads to the Matryoshka implication. Physicist Lee Smolin proposed cosmological natural selection. If black holes birth new universes, then universes reproduce. A universe with different laws of physics that cannot create stars is a genetic dead end. It has no offspring. But a universe like ours, finely tuned to create stars, creates billions of black holes. We are not an accident. We are the result of cosmic evolution. We live in a universe optimized for reproduction. So, do we live inside a black hole? The math allows it. The density calculations support it. And the holographic principle demands it. We are not lost in a random void. We are safe inside the shell of something much larger, incubating billions of other universes within our own dark depths. The next time you stare into the night sky, remember, you might not be looking out into the infinite. You might be looking at the walls of our cage or the shell of our egg.